Do the sides 3, 4, and 6 form an acute, right, or obtuse triangle? Give your reasoning. Again, wow. Do the sides 3, 4, and 6, those could be inches, feet, whatever, they're all same units, form an acute, right, or obtuse triangle? We're going to give the reasoning for it. All right, great starting problem there. Let's take a look at it here, see what we've got going on here. Got the situation. I already drew one option because we're thinking right is kind of in the middle. All right, a right triangle is right in the middle, and we can figure out what's going on. If we know 3 and 4, we know the two legs, we can figure out the hypotenuse. All right, we can use the Pythagorean theorem on that. And some of you say, I already know the answer to that part. Well, let's see what we've got. 3 squared plus 4 squared equals, we always like to call that third side C. Maybe it's a hypotenuse, maybe not, because if it's not a right triangle, we don't have a hypotenuse, you know that. So here we go, we got 9 plus 16, and that's going to give us C squared. We add that together, I get 25. Uh-oh. We square root. Why did I say uh-oh? Because it's going to give us 5. So 3, 4, 5 makes a right triangle. So we can say goodbye to the right triangle. It's not going to work. That would have been a 5 there. But what I want us to notice, we'll take that bottom out there just a little bit, guys, for me. Thank you. What we've got going here is there's a relationship. So if you were to keep the 3 and the 4, they had to be the same, what's going to happen is you've got that one's going up and one's going out. Stretch it a little bit. You're still going to have 3 and 4, but now you've stretched it to 6. Guess what? My angle down there, it's more obtuse. So it's going to be an obtuse. Now, I want to go back to the fact, can we prove that or can we convince you of that? I don't know if we want to say prove it, but can we convince you using the values here? And what happened here, if it had been a right triangle, it would be 3, 4, 5. Everybody agrees on that. Pythagorean theorem spells that out for us. What would happen? What actually happened here when we took 3 squared and 4 squared and we worked with 6 squared, it is not equal. We know that. We know that. That's going to be 25 over here. And this is 36. Folks, the way it's going to be obtuse is if this C squared, so to speak, or this third side, the longest side, by the way, do not put these in, do not put 6 and 4 together or 6 and 3. 6 has got to go over here, all right, when we do this little trick. I just thought about that. Better make sure we're all good on that. In this case, the sum of the two smallest pieces is smaller than the square of the third piece. Again, the sum of the squares, I need to put that squares in there. I realize I just didn't do that. So 3 squared plus 4 squared, we got 25. 6 squared is 36. That is going to signify that we have obtuse, all right? Now, what happens if that were to be a number, let's say, for example, we had another 4 in there? Well, you would know then it's isosceles, and the 4 and the 4 wouldn't work. So you know it would be doing something. But what we want to do, we would want to, let's say, put 4 1/2, all right? So we got 3 squared, and we got plus 4 squared, and we got this 4 1/2 squared. Now you say, why'd you pick 4 1/2 squared? I want something a little bit less than 5. I want a little something less than 5 because I know 5 is the magic moment for a right triangle. If I open it up a little bit more, open that angle more, that's going to have to stretch what was the hypotenuse was now going to become the third side. It's going to stretch it. So therefore, let's see what 4.5 gives us. Let me clear over here to the calculator, graph out. Maybe we can get it out. It's upset today. There we go, and clear. And let's do a little math here. How about it? Let's see, 4.5 raised to the second power. Wow. Put an equals on it, Ernie. There you go. How about it's 20.25? Well, we've got 25 over here. Over this one gives us 20 and a fourth. So guess what? We are now at a greater than situation. So in other words, the square root of the two smaller numbers added together come out to be greater than the square of the third number, which obviously has to be the larger, all right? So that becomes acute. So again, it's real easy. If they had been equal, we would have had a right, okay? In other words, if we had 3, 4, and 5, we did not. We have 3, 4, and 6. 6 presses it, stretches it a little bit more, gives us the obtuse relationship, all right? The acute brings it back a little, so it brings it back in. It's not quite as stretched. It's going to be a little less, which means we're going to have that angle opposite that third side is going to become smaller, which makes it an acute triangle. Remember, acute triangles have all angles acute. Obtuse has one obtuse angle and two acutes, and a right triangle has one right angle and two acute angles. So there's your story. Woo, what a mouthful there. Maybe more than you wanted to see, but that's how you can work them out. It's all about the Pythagorean, and that bases it for a right. If it doesn't work for right, then you're after it for an obtuse or an acute, all right? Hey, and sometimes it may not even make a triangle. That's another story. If the two sides here are equal, adding up to equal the third, or less than the third side. So in other words, this has been a 1 and a 4, we wouldn't even have a triangle. So that's also a little thing to throw in the game there.
For more math help, visit TNLearn.org.